All right, so for our first reaction here, okay, we have only one reactant and we have elements only as our product. So this is what kind of a reaction? Simple decomposition. All right, then we need to write it out in words. So this is trinitrogen dioxide. And then on this side, we have nitrogen and oxygen. Okay, remember that just because they are molecular elements, that does not change how we write them when they are by themselves. Okay, that is the only way we find nitrogen as an element. That is the only way we find oxygen as an element. They never come as a single when they're by themselves. All right, then we need to balance this thing. So right now it looks like oxygen is okay. The biggest number is nitrogen, okay, and it's a 3. So I've got 3 nitrogens over here, and I've got 2 over here, right? Since that's not balanced, what's the lowest common multiple of 2 and 3? 6. All right, so I'm going to try and make 6 on both sides. So I need to put a 2 over here and a 3 over here. Now I have 6 nitrogens on both sides. But by doing that, I've now made 4 oxygens on one side and only 2 on the other. So what needs to go in front of this? A 2, right? Because 2 times 2 will be 4. Okay, questions on number 1. Okay, for number 2 here, I've got a metal by itself reacting with an ionic compound to create a different metal by itself and a different ionic compound. What kind of reaction is that? A single replacement reaction. Okay. Write it out in words. We've got calcium plus iron 3 chloride. Okay, this is one of those times where we have to remember when something needs Roman numerals and how to put the right Roman numeral on there. Okay, and that is going to give us iron plus calcium chloride. Okay, why don't I put a Roman numeral on the iron on the other side? Yeah, it doesn't matter now. It doesn't have a charge. It's an element. Elements don't have a charge. It's by itself. Okay, that thing, iron would only need a Roman numeral if it's in a compound with something else. Okay, I only bring that up because sometimes I see people do that. Okay, they put a Roman numeral beside it when it's by itself. It doesn't need one then. Okay, now we've got to balance this thing. So right now there's 1 calcium on both sides, 1 iron on both sides, but the chlorines are not balanced. They've got this 3-2 problem we saw in the last one. Lowest common multiple of 2 and 3 is 6. So I'm going to multiply by 2 here, okay, and then by 3 over here. That balances my chlorines. But this 2 now means I need to have 2 irons on this side. This 3 means I now need 3 calcium over there, right? And then I'm balanced. Run all right with that one. Okay, questions there? Don't be afraid to ask if something's not making sense. Okay, chances are if it doesn't make sense to you, there's 4 or 5 other people it doesn't make sense to who are also too shy to ask. Okay, so make sure you ask. All right, number 3, what kind of reaction is number 3? It's a combustion reaction, right? We've got a hydrocarbon reacting with oxygen, and the products are CO2 and water. Okay, we see products as CO2 and water. It's almost always, okay, like 99% of the time, going to be a combustion reaction. Okay, so we will write combust beside it, and then we will write this out. Now, I don't know what I don't remember what the prefix for 14 is. Okay, so in a case like this, I would have already given you the name of this stuff, right? So that you would have it. This is in fact called hexane. Not that you'll ever need to know that, but that's what it's called. Actually, you will need to know it in Chem 20 when you take organic molecules. For now, you don't need it. Okay, plus oxygen. Okay, gives us carbon dioxide and water. Okay, what are the special balancing rules for combustion reactions? What order do I balance them in? Alphabetical order. Okay, what's the other rule? Right, with a rule of 2. Do I need both rules on this one? Yes, I do. I have an even number of carbons, so I need to start with a 2, and then I need to balance alphabetically. So 2 times 6 carbons is 12, so I need a 12 over here. Okay, 2 times 14 carbons is 28, Okay, so 14 times 2 is 28. And now I can balance my oxygens. 12 times 2 is 24, plus another 14 is 38. Okay, so there are 38 oxygens, and I'm pretty sure that 19 times 2 is 38. Okay. Everybody with me there? Yeah, sometimes the numbers get big on combustion reactions. They're about the only ones that'll have really big numbers, okay? But the more carbons you have, the bigger this number will get, okay? It becomes ridiculous, actually, okay? But when you start thinking about this, okay, in our vehicles, we burn octane, okay? That's the stuff you often see it on the pump. That's the difference between regular and mid-grade and premium is the amount of octane in the fuel, okay? So when we burn octane, we not only use a lot of oxygen, but we produce a lot of CO2, okay? And you think about how many, reactions or how many times that reaction occurs in your car while you're driving. Okay? It's a lot of carbon dioxide put out by every vehicle. Okay? Not that I buy into all that, global warming stuff, but okay, I mean, yes, the world is warming, but yeah, we won't get into that. That's an argument for another day. How many people have done 4 and 5? Okay, let's go over those two then. Okay, so for number 4, okay, we've got this element chlorine reacting with lithium to produce a single compound lithium chloride. Okay, so this would be a synthesis reaction. Okay, so like we said, chlorine plus lithium gives us lithium chloride. All right, and then we need to balance. Lithium's already balanced. Start with the largest number. Okay, that's our rule for everything other than combustion reactions. Okay, 2 is the largest number. So I'm going to go over here and make sure that I have 2 chlorines, but that means I need to have 2 lithiums, and now it's balanced. Okay, notice, guys, that I don't write the ones. Okay, you don't have to write the ones typically in a reaction unless this is a fill-in-the-blank question. Okay, if it's a fill-in-the-blank question, don't leave blanks blank. Right, put a 1 in the blank. Otherwise, it's hard for me to tell whether you didn't finish it or knew it was a 1. Okay, and I'd like to know that you knew it was a 1, so put a 1 in if it's a fill-in-the-blank question. Right, everybody got it? All right, for number 5, I have manganese 2. No, sorry, magnesium, not manganese. Magnesium fluoride. Okay, magnesium fluoride. Okay, plus cobalt-3 nitrate. Okay, giving us magnesium nitrate and cobalt-3 fluoride. Okay, what kind of reaction is that? A long one, yes, it is. It's what? Double replacement. They're all ionic compounds. Okay, you have 4 ionic compounds. It's a double replacement reaction. All right, then we got a balance. So I would say we could start with fluorine or nitrate. It doesn't really matter. Okay, each of them has a 3 on one side. I'll start with nitrate just because that's what I'm going to pick. So I've got 3 nitrates over here, 2 over there. Lowest common multiple is 6. Okay, so I'm going to put a 3 here to get me 6 nitrates. Okay, does everyone follow my math there? Right, okay, nitrate, I don't worry about this 3. Okay, that 3 tells me it's nitrate. The 2 tells me how many there are. Okay, so we got 2 over here. So 2 times 3 is 6. 3 times 2 is 6. Okay, when I put that 2 here, though, it then gives me 2 cobalts. So I need to go over here and make sure I have 2 cobalts. Okay, that gives me 6 fluorines. So I got to go back over here and make sure I have 6 fluorines, and that 3 happens to make my magnesium balance. Okay, so I know I did it right. Okay, how are we feeling about that stuff? Okay, that's the easy way. It's easier when they give you the formulas. When they give them to you like this, however, it tends to give people more trouble because now you have to get the formulas right. Okay? If you don't get the formulas right, it won't balance or it'll balance wrong. Okay, one way or the other. Usually it just won't balance. So when you're doing these ones, if you're trying to balance it and you can't get it to balance, chances are you wrote a formula wrong. Something as simple as, you know, screwing up a swap and drop somewhere, okay? But it usually means that one of your compounds is not written correctly. All right, I want you to try these ones, okay? Same thing, except now you're writing out the formula, identifying the type, and balancing. Okay, so for number 6, okay, we have copper 2 nitrates. All right, so the first thing we want to do here, guys, is write out all of the compounds that are involved. Okay, this is copper 2, so it's the copper that has the 2+ charge, and it's with nitrate, so that's NO3, which is a -1. So that's going to be NO3 2. Okay, and it is reacting with magnesium, so that's just Mg. Right, to form magnesium nitrate. Okay, this is a 2+, okay, with nitrate. So this is going to be MgNO3 2, okay, plus copper metal. All right, so it's really important that I make sure my drops and swaps are good. Otherwise, like I say, it's going to be hard to get this to balance correctly. All right, I have an ionic compound reacting with an element to form a new ionic compound in a different element. This is a, what kind of reaction? Single replacement. Okay, then we have to balance it. So, okay, good. It's balanced, right? There's 2 nitrates on both sides. There's 1 copper on both sides. There's 1 magnesium on both sides. It's already balanced. We don't need to put anything in for that one. All right. Questions on number 6? Okay. Number 7, okay? I don't even know what the name of this stuff is. We're going to call it fuel. Okay, but we're just going to write C12H26 here because that's all we have to do. Okay, C12H26, okay, is our fuel, right? And we are reacting that with oxygen gas, right, to produce carbon dioxide and water. All right, obviously it's a combustion reaction. And now we need to balance. So, do I need both rules on this one? Yeah, 12 is an even number. Okay, so we're going to have really, really big numbers here. Okay, 2 times 12 is 24. So we got 24 carbons there. Okay, and 2 times 26 is 52. All right, so we need 26 times 52, or times 2 over there to get 52. And then we have to get our oxygens. So 24 times 2 is 48. Okay, so we got 48 there, plus another 26, so 14, we're looking at 74. Yeah, 74 oxygens.
So would you do that one without people viewers on the 12?
I don't think so. I think we would get, we would still get a 0.5 here, wouldn't we? Yeah, still get a 0.5 if we do that. Okay, because I'll get an odd number of oxygens. When I divide an odd number, I get a 0.5, right? So it's not going to work. Okay, so 74 times 2 would be 37, right? Okay. 37 oxygens. Okay. All right, give you a couple more minutes to get the last 3 done there, and then we'll walk through those together. 8's tricky. Okay, 8's tricky for this reason. Decomposition reactions and single replacement reactions often produce molecular elements as products. And it's easy to forget molecular elements need a small number beside them. And if we forget those, then we either balance it completely wrong or it won't balance at all. Unfortunately, usually we just balance it wrong, okay, and then don't really know that we've done it wrong until we get it back. Okay, and it's been marked, and then it's been marked wrong. All right, so when we look at this, we have lithium nitride. So that's going to be Li3N, because this is a -3 and that's a +1. Okay, breaks down into nitrogen and lithium. Okay, lithium is a metal, so it's not going to need a little number beside it, but nitrogen is one of our highlighted molecular elements, and it always comes as a 2. All right, so now I need to balance this whole reaction. Okay, I could start with the lithium, okay, and put a 3 here, but then I would have to change this number because I've got 2 nitrogens here. Okay, I'm just kind of looking into the future a little bit. So I've got 2 nitrogens over here. I'm going to put a 2 here, okay, to balance my nitrogens, which then gives me 6 lithium. So a 6 here will make that work. Okay, so if you forgot the 2, you probably were still able to make the equation work, but not with those numbers. And obviously, if you just wrote N as a single, then it's not right because nitrogen doesn't come that way. Okay, everybody follow me there? How many people have done number 9? Okay, let's look at 9 then. So hydrogen sulfide. Okay, so we got hydrogen with sulfur. Okay, sulfur's a -2, hydrogen's a +1, so we're looking at H2S. Okay, reacts with calcium hydroxide, Ca with OH. OH is a -1 and calcium is a +2. So when we drop and swap, we've got that. And that is going to produce calcium sulfide. This is a -2, this is a +2, so that one works out. Okay, with hydrogen hydroxide or water. Okay, now here's the thing, guys. It says water there, but I'm going to write water as hydrogen hydroxide. And here's why I'm going to do that. It's easier for me to keep track of where everything came from. All right, I know I have a single hydrogen in the reactants and I have a hydroxide in the reactants. But if I write it as H2O, it's harder to track where everything went. Okay, this way I'm still matching up with what I started with. Does everyone follow me there? Because it's still correct. It's still H2O. I just didn't write it that way. Right? I wrote it as HOH instead. All right, so looking at our balancing here, on this side I have 2 hydrogens, and over here I only have 1 because this hydrogen's part of hydroxide. Right? So I'm going to put a 2 here to balance these 2 hydrogens here. When I do that, it gives me 2 hydroxides. And I have 2 hydroxides over here, so that worked out well. All right, I have 1 sulfur, 1 calcium, 1 calcium. The rest of it's good. All right, so oftentimes in replacement reactions, you will want to write water as HOH. In a combustion reaction, you're going to want to write it as H2O, okay? But in a replacement reaction, HOH is likely your best bet to write it. Okay, how many people have done number 10? All right, I'm going to give you a couple more minutes before I see a few more hands before we do that one. So for our last one, we have phosphorus. Now, how does phosphorus come when it's an element? It has a 4. Okay, reacts with oxygen, which comes as a 2, okay, to produce triphosphorus dioxide. Okay, so I don't have to drop and swap anything because everything in this reaction was molecular, and it's a what kind of reaction? Synthesis. Okay. Now, when we get a little further along, and you guys are actually predicting the products because you'll get there, okay, to the point where I won't have to tell you what the products are. You'll be able to predict them. Okay. I wouldn't give you one that involves a molecular compound because it's hard to predict those. Okay. It would be ionic where you could drop and swap. So in this one, we have a molecular, but we were told what the products were. What should I start with for my balancing? Phosphorus. It's the biggest number. It's usually best to start with the biggest number. All right, I got 4 phosphorus over here, and I've got 3 over here. Okay, what can both of those numbers go into? 12, yeah. All right, so I'm going to put a 3 here and a 4 here. That'll balance my phosphorus. Now I need to look at what did that do to my oxygens. It gave me 8 oxygens over here. Okay, so I need to put a 4 there, and now it's balanced. Something to watch for on your balancing, because sometimes this happens. Sometimes we pick the wrong number and we end up with this reaction, but we have it written this way. Whoop, I should make that a little smaller so those are messy. Okay, if I accidentally thought I should use a 6, okay, I'm going to get all my numbers being double. Okay, when I do that. Can I reduce those? While that is balanced, it's not the lowest form. Okay? It doesn't happen often, but it happens once in a while. So always check your numbers. If you can reduce them down. Okay? All right. How are we feeling about this? It's overwhelming, right? Like at first, it's a lot to digest. We're going to spend a fair amount of time practicing it. Okay, we're going to break it up, obviously, with a lab here probably this week, but we are going to be spending quite a bit of time practicing it. So I'm going to give you like a 2-3 minute break. Okay, just chat with your friends, check your phone, whatever. Okay, and then I'm going to put some other ones up here that I'm going to want you to try. All right, so you got 2 or 3 minute break here, then we're going to move on. All right, so we got a few worksheets here to kind of work on this. Like I say, today is going to be mostly I'm giving you the whole reaction, write it out in words, identify the type, balance it. Okay, but we are going to be moving towards, I only give you the reactants. You have to identify the type from that and predict the products and then balance. We're not there yet, but that's where we're moving to. Okay, so what I've got on the board here is the first worksheet. I just posted in Google Classroom the keys. All right, so if you go into Google Classroom, okay, the reaction worksheet keys file is there. So I would say like do 2 or 3 and then check. Okay, then check the key. All right, do 2 or 3 and then check the key. Obviously, I'm not taking this in for marks as I've posted the key. All right, so you don't have to worry about that part of it. It's not cheating. I've given you the answers. I want you to check them. Okay, if you're finding you're not getting them right, then you need to ask for some help. Okay, we need to figure out where you're going wrong. It's usually something simple. Okay, so don't be embarrassed. Just ask for some help, and I'll come over and we'll figure it out. Okay, so the keys are right there, right? And this is from your digital workbook. So if you'd rather have it on your phone where you can see it, that's fine. But it is, sorry, in your digital workbook, and it's on page 8. Okay, so it's on page 8 of your digital workbook if you're looking for it. Okay, so for these ones here, you are balancing the equation, writing the word reaction, and the type of reaction: synthesis, decomposition, single replacement, double replacement, or combustion.